Okay, so our first part is just writing those ratios. They just want us to create the fractions and then write the fractions as decimals. So if we are looking for sine of A, sine is which ones? So what is the sides in terms of sine?
Sine, it's on the calculator. You got to type it in.
It is a function on the calculator, that's true. Remember, some old hippie, so opposite over hypotenuse. So old opposite of A is which side length? It's 9, yep. Over the hypotenuse, which is? 15. Nice job. Okay, now if we were going to write that as a decimal, what would that decimal be? 9 divided by 15? Okay, let's wait. It's not guess if you don't know it.
I do know it. That's on the answer right. You said divide that.
It's what? So 9 divided by 15 should be 0.6. Okay, cosine of A. So some old hippie came a-hoppin'. A-H, a-hoppin'. A stands for adjacent. Which side is adjacent to A? Yeah, I think I heard it. 12 over your hypotenuse, which is 15. Okay, so now when we put that into our calculator, what's 12 divided by 15?
You're only going there one time, so 3. 1 remainder 3.
So you're doing 15 divided by 12, but it's 12 divided by 15.
Oh.
So you flipped it. So 3 goes into 12 4 times. 3 goes into 15 5 times. So you should end up with 0.8. Does that sound right? Okay. And then we have tangent. So tangent is through our apartment. Our apartment. Opposite of A. So which side is opposite of A?
C.
So 9 is opposite of A. Adjacent to A? 12, yep. So when you put that in your calculator, 9 divided by 12, what do you get? Yep, 0.75. Nice job, guys. Okay, our next one is sine of B. So sine, old hippie. So opposite of B is which side length? 12 over our hypotenuse, which is 15. You don't have to put in your calculator again because we already did this fraction right here. 0.8. So we can put 0.8 here. We also have cosine of B. So cosine came a-hoppin'. A-H. Adjacent over hypotenuse. Adjacent to B is 9. Hypotenuse is? Okay, we already did that one as well. It was the first question. What did we get for that for our decimal? 0.6. And then last but not least, we have tangent. Tangent is through our apartment. Opposite over adjacent. Opposite of B is over adjacent. 12 over 9, yep. And now when we put 12 divided by 9 in our calculator, what do we get? Lim, what'd you get?
Lim.
1.3 repeating. So if you haven't seen this before, we put the line over what's repeating. So the 3 is repeating.
Angle.
So if we are looking for the angle measure, yep. I'll highlight them as we go. So if you were looking for the angle measure and given at least 2 sides of the right triangle, we can find the missing angle of the right triangle by using the inverse denoted by sine inverse of x. You can use shift second to find this. And these are on your trig buttons or on your calculator. And you'll see it denoted with the -1 exponent. So over here, use the calculator to approximate the measure of angle D to the nearest tenth. And then we also want to do the same thing with angle F. So which trig function do you want to use to approximate angle D? Sine, cosine, or tangent? In this case, we're given all three sides, so it does not matter which one you choose. If we were only given two, that's when it would make a difference. So right now, it's just your preference. Does anybody have a favorite one, sine, cosine, or tangent?
I don't even know what that means. You can explain that?
So those are the trig functions we use to identify, using the ratios of the side lengths to find those angles. Okay. So my preference is always sine, but you do not have to use it. So I'm doing sine of angle D equals, sine is some old hippie, OH, opposite of angle D. What side is opposite of angle D? 30. Hypotenuse is 34. So if we want to find that angle measure, we have to apply the inverse. So you're doing sine inverse of 30 divided by 34. So remember that second second sine, and then you put in your fraction of 30 divided by 34, and that will give us our angle measure. So what is it? So I heard two of you guys 61.9? 61.9 degrees. So to find angle F, you can use any trig function. I can use, let's do tangent this time. Tangent of F. So some old hippie came a-hopping through our apartment. Opposite over adjacent. So tangent of F, so opposite of F is? Adjacent is? 30. So here we have tan inverse of 16 divided by 30, which equals? 28.07. So I'll round it up to 28.1. What do we notice about these two angles? So 61.9 and 28.1. We've talked about this before. What is that relationship, Carmen? They equal up to 90. Yep, they're complements. Add up to 90.
Gotcha, Miss Jen.
Okay, so for example 2, find the angle measure for P and M to the nearest tenth and also find side N. So which one do you guys want to do first? Find the side or find the angle? So let's find our angles. So if we're going to find our angles, we have angle M and angle P that we're trying to find. Which sides do we have in reference to angle P? Which sides do we have? So which side is the 5 on? Is it on opposite, adjacent, or hypotenuse? It's on opposite. What side is the 10 on? Adjacent. Which trig function deals with opposite and adjacent? Which one did you say? Tan. So we're going to have to use tangent because it's the only one that deals with opposite and adjacent. So our tangent of P equals, through our apartment, OA, we see opposite of P was 5. Adjacent to P is 10. So we now want to find that angle. We apply our inverse trig function. It is. It's tan inverse of 1/2. When you do tan inverse of 1/2, what value do you get? 26.5?
Hold on.
Degrees. Angle M, which sides do we have? 10 and 5. And which angles, or which sides are those in reference to the angle? So opposite. And 5 is? So which trig function are we using? So you have tan of M equals opposite over adjacent. Opposite of M is 10. Adjacent to M is 5. We're going to do tan inverse. We have tan inverse of 10 over 5, which is the same thing as tan inverse of 2. What is tan inverse of 2? 63.4. Okay, we have now found both angles. We have to find the missing side. How do we find the missing side? I didn't hear what you said, huh? I'm sorry. So we don't necessarily add them. We have a theorem, pretty famous theorem. Starts with a P. We're going to Pythagorean theorem it. So we know that n equals the square root of the side length of Pn squared plus, let's zoom in and make that a little nicer. Pn squared plus the side length of nm squared. So we substitute in those values, those distances. Pn is 10 squared plus nm, which is 5 squared. We end up with 100. Exactly right. We end up with square root of 125. When we do that, is that a perfect square?
Yeah.
It is not a perfect square.
And you can put all 25s in there though.
25 and 5?
Yeah.
25 and 5? 5 or 25 goes to 5 and 5. Circle what has buddies. So n equals, 5 square root of 5. So if we're looking for angle B, which side lengths do we have in reference to B? 45 in reference to B sidewise. Which one is that? It's the opposite. And then which one's this one? The hypotenuse. So we have opposite and hypotenuse. Which trig function has opposite and hypotenuse? Yep, so sine of B equals opposite over hypotenuse. Some old hippie. So we have sine of B equals opposite of B is 45. Hypotenuse is 53. We end up with sine inverse of 45 divided by 53 equaling what value? 58.1? Okay. 58.1 degrees. We also want to find C in reference to C, which side lengths do you have? Yep, and which sides are those in terms of opposite, adjacent, and hypotenuse? Yep, adjacent and hypotenuse. So that means we're using cosine. So cosine of C equals adjacent over hypotenuse came a hopping. Adjacent to C is 45. Hypotenuse is 53. So we find sine inverse of 45 over 53 equals what value?
Example 3.
We are indeed.
Yeah.
What's the name down there?
31 point.
It's 31
Point 9?
My car going back.
That's that car is dump.
That's 31 point. Yeah, 31 point.
Okay, so we have 31.9 degrees. We're also missing that side. When we're missing that side, we have to solve it. We can do that with the Pythagorean theorem. Remember, that is a squared plus b squared
Equals C squared.
equals c squared. We know that c squared is always your longest side. It's your hypotenuse. What value do we have for our hypotenuse? 53 squared.
He said why?
You can label these either direction, but what we would say is that 45 could be representative of the B. So 45 squared plus a squared. We want to get a by itself. So we're going to subtract over 45 squared. I have a squared equals 53 squared minus 45 squared. What is 53 squared?
If you multiply 53 times 50.
That is how you find it. But what did you say, Jaslyn? 2,809. Like that? Minus 45 squared, which is? 2,025. Like this? Okay, a squared equals 784. Square root both sides. Okay, now we have, I'm going to change my color so I can finish this. I have a equals the square root of 784. Did everybody arrive at 784? Okay, we are now going to factor that. What goes into 784? We know 2 does. 2 goes into it. 3, 9, 2. Is it a perfect square? That's easier. I appreciate it. So instead of doing that, since you know it's a perfect square, we could just use the 28s. Circle it. 28 is our answer. You know you're not supposed to be doing that. Okay, so to solve for these, we want to find our missing angle. We're going to apply the inverse button. So you now have sine inverse of 0.5. What is sine inverse of 0.5? 30. So it ends up being exactly 30 degrees. We now want to find cosine inverse of 0.92. Cosine inverse of 0.92. 23.1. And then last but not least, sine inverse of 0.1149. So, yep, we're going to have 66.0 degrees. So, scrap that. 6.60. 6.6 degrees.